8.2, solve by factoring notes. So this one takes what we did in 8.1 and puts it to the next level. So we're actually solving these this time instead of just factoring. So the first three are just a review of what's going on with factoring. So again, you do your A, which is 1, multiplied by your C, which is 20, and we get 20. So now we're looking for the factors of 20 that add up to a positive 9. So that's 4 and 5. 4 times 5 makes positive 20. 4 plus 5 makes positive 9. So because the A value is 1, you can just write your intercept form from there. So x plus 4, x plus 5. The next one is a little bit more difficult because your A value is 14 and your C value is 15, which equals 210. And we know that because it multiplies to make a positive and adds to make a negative, both factors have to be negative. So we have negative 10 and negative 21, which adds up to negative 31. So now we put it in our area model, the box thing. So we have your A value, 14b squared. We have our C value of a positive 15. And then we have our factors, negative 10, don't forget your x, negative 21, don't forget the x. All right, so at this point, I know to make a 14, I can do 1 times 14 or 2 times 7. Because I have that 21, I'm going to work with that 7. So I know that 14 and 21, both of these, can be divided by 7 evenly. So I'm going to put the 7b up here. And I call these x, and they're supposed to be b's. So b, b. So again, 7b times 2b makes 14b squared. So now how do you make a 2b into a 10b? If you multiply it by negative 5. And how do you make a 7b into a negative 21b? And that's if you multiply it by 3. Negative 5 times negative 3 makes positive 15. So we've set it up correctly. So now we can write our binomials. We have 7b minus 5 and 2b minus 3. So the last one I'm going to let you guys use to review, and we're going to move on. So this one, we are solving these equations now that they're factored out into two binomials. In order to do that, you just take each binomial and set it equal to 0. Because if 1 equals 0, the whole thing equals 0. So we have 6r minus 1 equals 0. And r plus 5 equals 0. And you solve each of these. So on the first one, first step, add 1 to both sides. You're left with 6r equals 1. Divide by 6 on both sides. And r equals 1/6. So that's 1 0 to this, 1 intercept, 1 solution to this quadratic. So if we plug in a 1/6, we'll get out a y value of 0. That's what this means. So for the other one, r plus 5. Subtract 5 on both sides to get rid of that plus 5, and we're left with r equals negative 5. So that's the other r value that would make this entire equation equal 0. Those are also your x-intercepts. Your x-intercepts are also referred to as roots and zeros. So then on our next one, same deal. They give us the two binomials, so we just set each of them equal to 0. P plus 1 equals 0, and P plus 6 equals 0. So when you solve them, subtract 1 on both sides, so P equals negative 1. Subtract 6 on both sides, and P equals negative 6. So again, those are your roots, your x-intercepts, your zeros. And we can write that on there. These are roots slash x-intercepts slash zeros. They can be called any of those three things. So now not all of them are already set up to be solved. So what you have to do on some of them is get them into those two binomials and then solve them. We've done a lot of problems like number 6 in getting them factored into those two binomials. So we're going to move down here to number 7. So the first thing I notice is that there's numbers on both sides of the equal sign. It's not already set equal to 0, so we have to get it equal to 0. So the way to do that is we have to move this 3k by adding it on both sides. So now we have 2k squared plus 3k minus 14 equals 0. So now we can go through and factor this. Make my k look a little better. So 3k is not a like term with anything on the left side of that equation, so you cannot combine it with anything. You just bring it down. So now we can factor this. We know that a is 2. A is 2. C is negative 14. So when you multiply those, you get negative 28. In order to make a negative, your factors have to be a positive and a negative, and we want them to add up to 3. So that means your bigger number has to be positive because that 3 is positive. So we have negative 1 times 28, negative 2 times 14, negative 4 times 7. So when we look through these add up to 27, these add up to 12, and these add up to 3. There's your b value of 3. So because the a value is 2, this is where we have to use the area model, aka the box thing, in order to figure out the two binomials. So first term always goes in the first box, 2k squared. Your c value always goes in that last box. And then your two factors, negative 4k and positive 7k, go here. So I know the only two factors of 2, that leading coefficient, the only two factors of 2 are 1 and 2. Because 2 does not go into 7, this k, that 1k has to go there, and the 2k has to go here. Again, we have to look at the relationship, our columns and our rows, to see where factors can go. So now I'm looking at k to positive 7k. So how do I make a k into a 7k? I multiply it by a positive 7. How do I make a 2k into a negative 4k? If I multiply it by negative 2. So now, to make sure it works, always check that last one. Check to make sure you can make your c value. Negative 2 times 7 is negative 14, which means we did this correctly. So let's go ahead and write our two binomials. So we have k minus 2 and 2k plus 7. And we're not finished. So this is solving by factoring. So now we've factored it. So now we have to solve it. So set each binomial equal to 0. K minus 2 equals 0. And 2k plus 7 equals 0. So when you add 2 to both sides, k equals 2. And then for the other one, subtract 7 from both sides. 2k equals negative 7. Divide to get rid of your coefficient 2. And k equals negative 7 over 2, or negative 3.5. So those are your two x-intercepts, your zeros, your roots. So the other two problems are set up very similar. I do want to do number 9 with you guys because number 8 already has the standard form on one side of the equation. So on number 9, To move that 11x, you have to subtract it. To move that negative 28, you have to add it. None of those are like terms on that left side. So this goes away and this goes away, and we're left with x squared minus 11x plus 28 equals 0. So because this has an a value of 1, it's quick, it's easy, we can knock this out. We've got 1 is our a value, c is 28. We know that the product is 28. The sum of the factors has to be a negative 11. So to make a product of positive 28 and a sum of negative 11, both factors have to be negative. So negative 1, negative 28, negative 2, negative 14, negative 4, and negative 7. Sum of negative 29, sum of negative 16, sum of negative 11. There's your factors. And again, because your a value is 1, you can simply just go ahead and write your binomials and then solve it. So first binomial, set it equal to 0. Second binomial, set it equal to 0, and then solve each of them. Add 4 to both sides, x equals 4. Add 7 to both sides, and x equals 7. Those are your roots, your zeros, your x-intercepts. So when you look at the next page, these are a little bit different because they have a GCF, a greatest common factor. So we want to pull out what they have in common before we solve them. So looking at this first one, we have k squared minus 4k. With both of them, I said k. So we're going to divide both of these by k and move the k to the outside. K squared divided by k is k. Negative 4 divided by k is negative 4. So this one doesn't have an equal 0, so we're just going to stop after we've found the greatest common factor and pulled it from that equation, or that expression. So this one's the same way. We have 4x squared minus 16x. They both have an x, but the coefficients are factors of 4, or are multiples of 4. So we're going to factor out a 4 and an x from both of them because 4 goes into both 4 and 16. So we move our 4x to the outside, and 4x squared divided by 4x is just an x, and negative 16x divided by 4x is negative 4. Now, sometimes you're going to end up having to solve them after you've taken that greatest common factor out. So on this one, I see that both of these are multiples of 5, so I'm going to divide by 5, and they both have an x, so I'm going to put that x. So the 5x moves to the outside. 10x squared divided by 5x is 2x. 15x divided by 5x is 3. So this one, they want us to solve it. So you take each part of this, 5x equals 0, and the other part of it, 2x plus 3 equals 0. And that's what we're solving. So we're going to divide both sides by 5, which means your x value equals 0 because 0 divided by 5 is 0. On the other one, subtract 3, you get 2x equals negative 3 divided by 2, and x is negative 3 over 2, which is the same as negative 1.5. So I want you guys to try to find the commonalities between these and finish this paper, then check your answers on Canvas later. One other one I do want to look at is this one. They both have an x squared in common. When you do x cubed divided by x squared, you get x. And 10x squared divided by x squared is 10. If it has an equal 0, make sure you solve it. One last one to go over is these with perfect squares. So this one would be x, and we know 8 makes 16. So the only way to make a negative 64 using perfect squares is if one of them's positive and the other's negative. Anytime you have a c value that's a perfect square and an a value that's a perfect square, you can do this. One more. Square root of 4x squared is 2x. Square root of -1 is 1. To make a -1, you have to have a positive and a negative.